Hello everyone, welcome back to my channel. In this video, I'm going to discuss NCERT Class 10 Math, Chapter 4, Quadratic Equations. So let's first try to understand what is a quadratic equation. An equation in which the highest power of the variable is 2 is called a quadratic equation. Okay? In an equation, if the highest power of the variable is 2, then that equation is called a quadratic equation. And the general form of quadratic equation is ax squared plus bx plus c equal to 0. So this is the general form of a quadratic equation. Any quadratic equation should always be in this form. Here x is the variable and this a, b, c. This a is any non-zero real number. Non-zero real number. Here your a is any non-zero real number, whereas b and c are any real number. Okay. A should be a non-zero real number and b and c can be any real number. Why a is a non-zero real number? Because if a is 0, then your equation becomes 0 times x squared plus bx plus c equal to 0. In that case, your equation reduces to bx plus c equal to 0, which is no longer a quadratic equation, but it becomes a linear equation. So for a quadratic equation, okay, the general form is ax squared plus bx plus c equal to 0, where a is a non-zero real number. Okay, so any equation which is of this form will be called as quadratic equation. Now let me solve the first exercise of this chapter 4, exercise 4.1. Exercise 4.1. Okay, the first question. Check whether the following are quadratic equations. Check whether the following equations are quadratic equations. Quadratic equations. Okay. The first one is x plus 1 holding square, x plus 1 holding square is equal to 2 times of x minus 3. That is your first one. Your second one is x squared minus 2x is equal to minus 2 times 3 minus x. Minus 2 times 3 minus x. So these are the first two questions of question number 1. Let us see. Okay, these are your given equation. Okay, in Roman 1, this is your given equation. If we can convert this equation, in the form of ax squared plus bx plus c equal to 0, if we can convert the above equation in this form, then that given equation will be called as quadratic equation. Okay? So let's see whether they can be reduced in the form of ax squared plus bx plus c equal to 0. Now this is the first question is of the form. Here on the left side we have x plus 1 holding square, which is of the form a plus b holding square. And the identity of a plus b holding square is a squared plus twice AB plus B squared, right? Okay. On the right side, okay, we are going to multiply both of these terms by 2. 2 into x twice x minus 2 3 times is 6. Now this implies x squared plus twice x plus 1 squared is 1. Let me transpose the other terms on the left side, the terms on the right side to left side. So 2x gets transposed as minus 2x minus 6s plus 6, and on the right side we have now 0. So this implies x squared here plus 2x minus 2x cancels out each other, and then we have 1 plus 6 is 7 equal to 0. Now this equation is now of the form ax squared plus bx plus c equal to 0, right? Okay, here there is no term containing x, right? Because here your b is 0. Okay, so since the given equation has been reduced, has been converted to this form, okay, so this particular given equation is a quadratic equation, or you can say that in this equation, since the highest power of the variable is 2, so this equation is a quadratic equation, okay? Or this x squared plus 7 equal to 0 is of this form, ax squared plus bx plus c equal to 0. It is of this form, where your b is 0, so there is no term containing x. B can be any 0 or non-zero real number, okay? Except that a should not be 0. So since the equation, okay, is of this form, ax squared plus bx plus c equal to 0, so this equation is a quadratic equation. Okay. Therefore, it is a quadratic equation. Now let us look at the second one. Let us simplify. X squared minus twice x is equal to, both of these terms has to be multiplied with this minus 2. Minus 2 times 3 is minus 6. Minus 2 times minus x minus minus plus 2 into x is 2x. Now let us transpose the terms on the right side to left side. Then x squared minus 2x minus 6 gets transposed as plus 6. And plus 2x gets transposed as minus 2x and then equal to 0. So we have here x squared minus 2x gives you minus 4x and then plus 6 equal to 0. Clearly, this equation is in the form ax squared plus bx plus c equal to 0. Okay. Here your a is 1, coefficient of x squared is 1. Your b is minus 4, your c is 6. So since this equation is of this form, so the given equation is a quadratic equation. Alright? Okay. Let us proceed with the next one, the third one, Roman number 3, question number 1, Roman number 3. Question number 1, Roman 3. Okay, we have x minus 2 times x plus 1. X plus 1 is equal to x minus 1 times x plus 3. X minus 1 times x plus 3. And Roman 4, in Roman 4 we have x minus 3 times x minus 3 times twice x plus 1 is equal to x times x plus 5. Now let us see whether it is a quadratic equation. Okay, we need to rearrange this equation, and if it is in the form of ax squared plus bx plus c equal to 0, then it is a quadratic equation. So on the left side, we need to multiply x minus 2 and x plus 1. So let us multiply. X into x gives you x square. X into 1 gives you 1x, or simply x. Minus 2 times x is minus 2x. Minus 2 times 1 is minus 2. Equal to, on the right side, we multiply this. X times x is x square, plus x times 3 is 3x. Minus 1 times x is minus x. Minus 1 times 3 is minus 3. We can add or subtract the like terms. X squared here, x and minus 2x are like terms. So x minus 2x minus x, and then we have minus 2 equal to x squared, 3x minus x, we have 2x and then minus 3. Let us transpose the terms on the right side to left side. Then we have x squared minus x minus 2. X squared gets transposed as minus x squared, plus 2x is minus 2x, minus 3s plus 3 equal to 0. X squared and minus x squared cancels out. So we have minus 2x minus x is minus 3x. And then we have 3 minus 2s, 1 equal to 0. Now this is the final form of this equation, okay? Since in this equation the highest power of the variable is only 1, okay? That means it is not in the form of ax squared plus bx plus c equal to 0. It is not of this form because here the term containing x squared is missing. That means a is 0. But for a quadratic equation, a cannot be 0. So since this equation is not of this form, or we can say that since the highest power of the variable is not 2, so this equation, this particular equation is not a quadratic equation. Therefore, it is not a quadratic equation. Why? Because the order of the equation is 1. Okay, so if the order of the equation is 1, then that is a linear equation and not quadratic. Let us see the fourth one, Roman 4. We multiply these two terms, okay? X into 2x, 2x squared, plus x into 1, x. Minus 3 times 2x is minus 6x. Minus 3 times 1 is minus 3. Is equal to x into x, x squared, plus x into 5, 5x. 2x squared, okay, we can add or subtract the like terms. X minus 6x gives you minus 5x, and then we have minus 3 equals to x squared plus 5x. Let us transpose the terms on the right side to the left side. Then we have twice x squared minus 5x minus 3, and then we have minus x squared minus 5x equal to 0. Twice x squared minus x squared gives you 1x squared. Minus 5x minus 5x gives you minus 10x, and then we have minus 3 equal to 0. Now since the highest power of the variable in this equation is 2, so order is 2, degree is 2, so therefore this equation is a quadratic equation. Therefore it is a quadratic equation. Alright? Okay. Now we will see Roman 5 and Roman 6. In Roman 5 is the same as that of Roman 3, okay, so you can try that by yourself. Let me go for Roman 6 and Roman 7. Roman 6, x squared plus 3x plus 1 is equal to x minus 2 holding square. And in Roman 7, we have x plus 2 cube is equal to twice x of x squared minus 1. So let us solve this Roman 6 and 7. Here there is nothing to arrange on the left side. On the left side, okay, we just leave the terms as it is. On the right side, okay, we have x minus 2 holding square. Now this is of the form a minus b holding square. So the identity of a minus b holding square is a square minus twice ab plus your b square. Okay? Now this implies x squared plus 3x plus 1 equal to x squared minus 4x plus 4. Let us transpose the terms on the right side to the left side. X squared plus 3x plus 1, and then we have minus x squared, and then we have plus 4x, and then we have minus 4 equal to 0. X squared minus x squared cancels out. 3x plus 4x, 7x, 1 minus 4 minus 3 equal to 0. Now this equation is not of the form ax squared plus bx plus c equal to 0. The term containing x squared is missing here, right? So this equation, see, in this equation, since the highest power of the variable is 1 only, so this is not a quadratic equation, instead it is a linear equation. Because the highest power of the variable is 1, order is 1. Therefore, it is not a quadratic equation. Now let us look at Roman 7. In Roman 7, on the left side, we have the identity a plus b holding cube. Here x plus 2 holding cube is of the form a plus b holding cube. So a plus b holding cube is given by the formula a cube, right? A cube plus 3a squared b plus 3a b squared plus b cube. Alright, a plus b holding cube is given by a cube plus 3a squared b plus 3ab squared plus b cube. And then on the right side, we multiply both of these terms by 2x. 2x times x squared, 2x cube, minus 2x times 1 is 2x. Now this implies x cubed plus 3 2 times is 6 and then x squared. Okay. 2 squared is 4, 4 3 times is 12, so 12x, 2 cube is 8. Now let us transpose the terms on the right side to the left side. Then we have minus 2x cubed plus 2x is equal to 0. Now let us simplify the like terms. X cubed minus 2x cubed gives you minus 1x cubed. Okay. We have only one term containing x squared, that is 6x squared. 12x plus 2x is 14x, and then we have plus 8 equal to 0. Now in this equation, since the highest power of the variable is 3, here the highest power of the variable x is 3, that means the order of the equation is 3. And if the order of the equation is 3, that's a cubic equation, not a quadratic equation. Therefore, it is not a quadratic equation. That's all. That's all from question number 1. So we have question number 2 now. Okay, question number 2. We need to represent the following situation in the form of quadratic equations. We need not simplify, okay? We just need to represent the following situations in the form of quadratic equation. So the first one, question number 2, Roman 1. The area of a rectangular plot is 528 square meter. So there is a rectangular plot and the area of the rectangle is given to be 528 square meter. The length of the plot is 1 more than twice its breadth. Okay? The length of the plot, the length of the rectangle is 1 more than twice its breadth. That means you multiply the breadth by 2 and add 1 more meters. Then that gives you the length. I'm repeating. You multiply the breadth by 2 and add 1 more meter. Then that gives you the length. Our aim is to find the length and breadth of the rectangle. So in order to find the length and breadth of the rectangle, we need to represent this situation in the form of quadratic equation. So it is given that the area of your plot is 528 square meters. Okay. Area of the plot is given to be 528 square meters. The length is given in terms of breadth, right? If you multiply the breadth by 2 and add 1 more meters, then that gives you the length. But you need to represent breadth by a certain quantity. So what I'm going to do is, let the breadth of the rectangular plot be x meters. So if you consider the length of the rectangular plot to be x meters, then the length of the plot will be, how do you obtain the length? 1 more than twice the breadth. So you multiply breadth by 2 and add 1 more meter. Then that gives you the length of the plot. Multiply the breadth by 2. So 2x and add 1 more meters. That gives you the length. Now we know that the area of the rectangle is given by length into breadth. So according to the question, length into breadth of the rectangle gives you the area of the rectangle. Length of the rectangle is twice x plus 1 times the breadth of the rectangle is x. Area is given to be 528 square meters. So twice x into x, twice x square plus 1 into x gives you x. And then let's transpose these terms on the right side to the left side. Then minus 528 equal to 0. Now look at this equation. Is the equation in the form ax squared plus bx plus c equal to 0? Yes. Here, since in this equation the highest power of the variable is 2, so since the order of the equation is 2, so we have represented the given situation in the form of quadratic equation. That's all. Okay, that's all. Now let us go for Roman 2. So in Roman 2, the given situation is product of two consecutive positive integers is 306. We need to find those two integers. When you talk about positive integers, then we are talking about the natural numbers. Natural numbers are your positive integers. So positive integers means numbers starting from 1, 2, 3, 4, 5, 6 up to infinity, right? There is an uncountable number of positive integers, okay? So these numbers represents your positive integers. So we need two consecutive positive integers. So if we choose 3 as your first positive integer, the next positive integer will be 4. Immediate one, consecutive, without any gap, right? So if we choose this 3 as your first positive integer, then its next positive integer can be obtained by adding 1 to the first positive integer, because 3 plus 1 gives you 4. If you are choosing 99 as your first positive integer, then the next positive integer can be obtained by adding 1. 99 plus 1, 100. So 99 and 100 are two consecutive positive integers. So the same way here, the question is talking about two consecutive positive integers. So in that case, if we choose x as your first positive integer, then the next positive integer can be obtained by adding 1 to this first positive integer. So the next positive integer will be x plus 1. So x and x plus 1 are two consecutive positive integers. Alright? Okay. So question is talking about two consecutive positive integers. So if I take one of the positive integer to be x, the next positive integer will be given by adding 1 to the previous positive integer. So that will be x plus 1. So I'm going to write, let the two consecutive positive integers So let the two consecutive positive integers be x and x plus 1. So x and x plus 1 are two consecutive positive integers. Question says the product of these two integers is equal to 306. So according to the question, product of the two integers, so x times x plus 1 is equal to 306. See, our aim is not to find the x, our aim is just to form a quadratic equation from the given situation. So here your x times x will be x square plus x times 1 is x is equal to 306. Let us transpose x square plus x, 306, you transpose to the left side, then it becomes minus 306 equal to 0. Now look at this equation. This equation is in the form ax square plus bx plus c equal to 0, right? Or since the highest power of the variable in this equation is 2, variable is x, the highest power of x is 2, so order is 2. Therefore, the given situation has been represented in the form of quadratic equation. So, question number 2, Roman 3. Let us read the given situation. Rohan's mother is 26 years older than him. That means currently means at present, okay? Rohan's mother is 26 years older than Rohan. Currently, okay? At this present, currently means at present, okay? Rohan's mother is 26 years, okay, older than Rohan. The product of their ages 3 years from now. Means after 3 years, if you multiply Rohan's mother's age and Rohan's age, after 3 years, if you multiply Rohan and his mother's age, okay, then that product would be equal to 360. We would like to find Rohan's present age. See, currently, Rohan's mother is 26 years older than Rohan. Okay, that means if Rohan's age is X years, then his mother's age will be 26 years more than him. That would be equal to X plus 26, right? So I'm going to take let Rohan's present age be X years. Currently, Rohan is X years old. Then his mother is 26 years older than him. 26 years more than Rohan's age. So in that case, Rohan's mother's age will be X plus 26 years. Rohan's mother present age. Because question says currently Rohan's mother is 26 years older than Rohan. So Rohan's mother present age is going to be X plus 26 years old. Okay? Now, product of the ages 3 years from now. Means after 3 years, when you multiply Rohan's age and his mother's age, that product will be equal to 360. So let us see after 3 years what will be Rohan's age and what will be his mother's age. So 3 years later, 3 years from now means after 3 years or 3 years later. Currently, if Rohan is X years old, then after 3 years his age will increase by 3 years, right? Right? So 3 years later, Rohan's age will be, okay, Rohan's present age is X years. After 3 years, his age will increase by 3 more years. After 3 years, his age will increase by 3 more years. So after 3 years, Rohan's age will be given by X plus 3 years, X plus 3 years, and his mother's age, okay, currently his mother's age is X plus 26 years. So after 3 years, his mother age will also increase by 3 more years. So her current age plus 3 more years, that will be X plus 29 years. So after 3 years, Rohan will be X plus 3 years old, and his mother will be X plus 29 years old. Now, according to the question, after 3 years, product of their ages will be equal to 360 degrees. So, product of Rohan's age and his mother's age, product of their ages will be equal to 360. Now we have to multiply these two quantities, x into x square, x into 29, 29x, plus 3 into x, 3x, plus 3 times 29. 3 9 times is 27. We have to carry 3 2 times is 6, 7, 8 is equal to 360. So x square plus 29 plus 3, 32x, plus 87 minus 360 is equal to 0. This gives you x square plus 32x, 87 minus 360. Minus 360 plus 87. 10 minus 7, 3. We have 5 over here. 15 minus 8, 7, and then we have 2. So 87 minus 360 will be equal to minus 273 equal to 0. Now this is your final equation. Since your resultant equation, okay, in your resultant equation, the highest power of x is 2. So the highest power of the variable is 2. So this is an equation of order 2. So it represents a quadratic equation. So the given situation has been represented in the form of quadratic equation. So the last question of this exercise, Roman 4, question number 2, Roman 4. A train travels a distance of 480 km at a uniform speed. If the speed had been 8 km per hour less, that means the speed is decreased. If the speed is decreased by 8 units, then it would take 3 hours more than the usual time for covering the same distance. We need to find what is the usual speed of the train. Okay, so I'm going to start up with let the usual speed of train be x kilometer per hour. Okay, distance is given in kilometers, time in terms of hours, so the speed will be expressed as kilometer per hour. Now, if the speed of the train had been 8 km per hour less, that means if the speed of the train is reduced by 8 units, then its original speed. Its usual speed is x km per hour. Now if the speed decreases by 8 units, then its usual speed. That means the speed of the train will now be x minus 8 km per hour. Usual speed is x. This time the speed of the train has been reduced by 8 units. So the new speed or the decreased speed of the train will be x minus 8. Then if the speed of the train decreases by 8 units, means 8 km per hour, okay, then it will take 3 hours more than the usual time for covering the same distance. Okay, so question says, okay, if the speed of the train decreases by 8 units, okay, then it will take 3 hours more. So I'm going to write here reduced speed of the train. Reduced speed of the train. See, actually the train usually goes at a speed of x km per hour. But this time, due to some situation, the speed of the train decreases by 8 units than its original speed. So the reduced speed of the train will be x minus 8 km per hour. Okay, speed of the train has been decreased by 8 units than its original speed. So the new speed of the train will now be x minus 8 km per hour. Speed has been decreased. Okay. Then, if the speed is reduced, the train would take more time, means 3 hours more for covering the same distance. Okay, that means time taken by the train after reducing the speed. Time taken by the train after reducing the speed will be 3 hours more than the time taken during the usual speed. Alright? Okay? Time taken by the train after decreasing its speed, okay, will be 3 hours more. 3 hours more than the time taken during the usual speed for covering the same distance. So time can be expressed as distance upon speed. Distance covered by the train is 480 km. Upon speed, reduced speed of the train is x minus 8. Time taken by, again time is distance upon speed. Distance is 480 kilometers upon speed. Usual speed of the train is x. And then we have plus 3. So 480 upon x minus 8, let us transpose this term to the left side as minus 480 upon x. 480 upon x is equal to 3. Now we can take LCM and simplify. Okay, the first denominator is x minus 8. Second denominator is only x. Okay, x minus 8 and x, they are not multiple of each other. So the LCM will be the product of denominators. So first denominator into second denominator will be your LCM. Now this product, this LCM will be divided by your first denominator. If you divide this term by this x minus 8, then x minus 8 cancels out. So we have only x. So x times 480 is 480x. Minus, we have minus. X minus 8 times x will now be divided by x. Then x cancels out. So x minus 8 times 480. So x minus 8 times 480. And then on the other side we have 3. So 480x minus 480 times x is 480x minus minus plus 480 times 8, 8 zeros are 0, 8 8s are 64, 4 6 carry, 8 4s are 32 plus 6, 38 upon x into x square minus 8 into x, 8x is equal to 3. We can cancel out these two terms, alright? So we have 3840 upon x square minus 8x is equal to 3. So we can cross multiply. If we cross multiply, 3 times of x square minus 8x is equal to 3840. If we further simplify, then what do we have is, okay, instead of multiplying both of these two terms by 3, I can transpose this 3 to the other side and divide 3840 by 3. So x square minus 8x equals to 3840 upon 3. We can divide 3 1 times is 3. 3 2 times is 6. 2 carry. 3 8 times is 24. 0. So x square minus 8x is 1280. So x square minus 8x minus 1280 is 0. Now look at this equation. This is an equation with variable x, and we see that the highest power of the x is 2. So since the order of the equation is 2, so the given situation has been represented in the form of quadratic equation. So with this question, exercise 4.1 comes to an end.